The show is yours.
Thanks, Lars. Somebody told me that when you arrive here at KITP, the first 2 weeks you don't get anything done because you're just amazed by the surroundings. And I'm still amazed. Looking, the Pacific Ocean is 50 meters from there. I think that's incredible. We all think, everybody in this room thinks science is important. Kids are naturally curious about the world, and taxpayers, they like to know where their tax money is going. Government thinks that science is important. They throw a lot of money at it, maybe not as much as you would like, but lots of money. And so science is a terrific thing. Unfortunately, scientists still speak Latin. Isaac Newton published Principia Mathematica in Latin, and you've been using Latin ever since. And by that I mean colloquially that you're speaking in a language that's pretty tough to understand. And so we need interlocutors, and that's where I come in, somebody like me. I've spent my life doing, what advances the slides?
You have to hit the button
on the computer, okay. I've largely done what might be called short-form journalism. In the old days, before there was email, we actually wrote press releases on paper and sent them out to journalists, and everything traveled at the speed of the United States Postal Service. I worked for the American Institute of Physics for many years, and they lent me out to the American Physical Society. So for about 30 years, I was in charge of publicity for APS journals and meetings, and this is a press release I wrote about a topic that'll be coming up a little later in the talk. Then when the internet became available and email, I started to compose my thoughts and what I knew about physics and stuff coming up in PhysRev letters, but also things happening in nature and physics meetings in general in a newsletter called Physics News Update. And although I didn't work for Physics Today directly, they were down the hall, and their news pieces were very long, very ponderous, and they resisted the idea of having these short little nuggets. Now we all take it for granted. But finally, we started up a page on Physics Today called Physics Update, and it's still one of the most popular pages in the magazine. But mostly what I'm going to talk about today is physics press conferences where the really biggest of the big results are announced, and I want to tell you a little bit about some of the inside things that happen in that regard. Yesterday, so you might ask, am I Don Draper? Am I selling, publicity, press conference? Some people consider those to be dirty words, a shabby exercise. I wish I looked like Don Draper, but no, I'm not Don Draper. This is not Mad Men we're talking about. I like to think that for all those years I wasn't selling toothpaste. I was selling physics in whatever form it comes. What we do, because I was having a conversation with Lars and then with David Nelson yesterday about some stumbles along the way toward making physics discoveries public. That gentleman at the top there is Heinrich Schern, and a few years ago you may have heard the name outright fraud, a case of outright fraud. His boss, Bertram Batlogg, claims to have been taken in completely. Many papers, reports of superconducting, semiconducting samples were withdrawn. These were peer-reviewed papers. And I meant to say, even for topics, subjects that have the press conference treatment, there's almost always peer review at work. So it's not as though anybody's giving up the peer review process. Good physics results should always be looked at in great detail. A more recent subject is the report of polarization in the cosmic microwave background a few years ago, seemingly confirming the inflationary model, and there was big hoopla. And a year later, the people reporting that were the BICEP 2 detector at the South Pole. Their competitor, the Planck, the orbiting Planck satellite, weighed in with results that showed no. The other group must have made a mistake in their calculation of background dust, and they had to withdraw that information. Now, freshest of all is Lars brought this to my attention a few days ago that LIGO might be reporting gravity waves. And I hadn't heard that rumor, so I looked it up. Nature reported the rumor a couple of months ago. Rumors are fair game nowadays. That's just the way the world works. If not in Nature, then certainly all over the web. Just 10 minutes before coming over here to give this talk, I was called by an Associated Press reporter who said, there's a rumor of a LIGO press conference. Can you give me the names of some non-LIGO gravity wave experts? So I did. So gee, that would be neat if this happens, and we'll know, maybe tomorrow when you get back to your office, there'll be a New York Times report about gravity waves. That's how it works. It's really exciting.
So why, you're focusing one on an outright fraud, which at best exemplifies not the press, but the miserable peer review
Indeed.
of science and nature.
Yeah. I'm just getting this stuff out of the way because
it's a totally kind of unreal mixture.
It is. I'm just showing things that can go wrong in the bringing of physics results to the public, and I'm getting that out of the way. These are the topics I will be giving more discussion to. 8.5 press conferences, ITC, superconductivity, quasi-crystals, directed energy weapons, which is a physics topic, cold fusion, microwave background in the 1990s, stoplight. I might be running out of time by that point. There's a nice 2-minute movie that made its debut at a press conference of ours. If you want to come back after the talk, I can show that. It's a very interesting movie made in 1927. This is a picture of Stephen Hawking at the APS Centennial meeting in 1999. I won't have time to talk about him. All right, so the first topic I'm going to dwell on is high-temperature superconductivity, and I'll just spend a moment talking about the history of superconductivity, and exciting subjects for experimentalists and theorists. The temperature rose, the high temperature, the critical temperature stayed didn't get out of the 20s until 1986. And then there were some reports of materials, perovskite ceramics of all things, a terrible conductor, excellent superconductor. Who would have thought? These two guys are Bednorz and Muller were their names, IBM Zurich. They were about to give up on the research, but they hung in there and created a minor revolution. This caused other researchers around the world, in the best tradition of science, to go out and to try and reproduce their results or get something even better. And Paul Chu at the University of Houston found a material that went superconducting at 90 degrees, which puts you above liquid nitrogen. And so there was a bonanza. The next big physics meeting that came up was the March 1987 meeting in New York City. Last time APS has had a meeting in New York, the room rates are too high. And that is Philip Anderson there. 2,000 or 3,000 people squeezed into a room fit for about 1,000 people. It was just pandemonium. And it has come to have the sobriquet, the Woodstock of physics. That's the first Woodstock. It didn't look anything like that, but it was pretty crowded. And this was, so we had 53 speakers, I think, and the talks went until 5. Jim, were you there? I bet you were.
Well, I should leave.
This is the press conference, one of two. We've only had 2 press conferences. There were so many results, so many interesting things to report that we actually had 2 back-to-back press conferences. And that's me there. I just wanted to show you that I wasn't making this all up. I was actually there. See the bow tie? In the New York Hilton. And Bednorz and Muller won the Nobel Prize later that same year, 1987. That's a friend of mine, Paul Grant, from IBM, and he's there on the cover of Newsweek. And that's the report I wrote that week in 1987 about what happened. I was the only one practically around who wrote press releases about a topic after the thing appeared. I guess maybe I wanted to be a journalist and not just a flack for physics, and that was my way of doing it. But that morphed into my newsletter later on. Did I hype the subject? I don't think so. Did the reporters, did Newsweek hype the subject? Here they have it on the front cover. If you read the articles, nobody promised maglev trains, within 6 months or 6 years even. Still, it's a neat thing that if you go from, I forget, liquid helium costs has a cost of about the same thing as cognac, and liquid nitrogen, I understand, is cheaper than beer. So all the superconducting devices around the world are going to use this material, right? In that regard, they got it wrong. High TC is still not much of a player anywhere, mainly because the material is so brittle. It's like trying to make wire out of a toilet bowl. And it's hard to extrude, hard to make. They do now make miles of it in high density environment like the Wall Street area. They may do superconducting wires there to transport power just from one side of Manhattan to the other, because more than the energy saving is the power density. The current is much higher for superconducting materials. To show you the richness of that Woodstock, that meeting.
This example in the KITP tradition really is a combination of two hypes, or two excitements, if you will. One was the technological possibilities of ITC, but the other was the theorists' hype. The theorists jumped on this and said, oh, this is a new kind of phase of matter.
Has BCS been ruled out?
You see, this is something else. This is fantastic. So, it really was that combination. I think if it had just been technology, it wouldn't have been as big.
But there's been a lot of good theoretical work since. Yeah, still not. They haven't arrived. Look how long it took Bardeen to come up with the theory of low temperature superconductivity. Same meeting, down the hall, another Nobel Prize. Daniel Shechtman, I think he's an Israeli scientist who was doing an experiment at what was then called the National Bureau of Standards, now called NIST. And that is Paul Steinhardt, who is a double threat. He's a cosmologist and he's a terrific condensed matter theorist. There may have been 50 or 60 reporters at the Superconductivity press conference, about a half a dozen at this one. Now, I don't know, maybe somebody can tell us here if there are any practical applications or...
But the science room was packed.
Yeah. The really interesting feature here, it's sociology, is this man here in the corner, one of the greatest scientists, not just a great scientist, but one of the greatest of all time, Linus Pauling. He's the guy who brought chemistry and quantum mechanics together in 1930 or thereabouts. Discovered the structure of hemoglobin. Biological physics could say a lot more. And nearly had the structure for DNA, except that Watson and Crick beat him out. Nobel Prize also, he won the Nobel Peace Prize, the only person ever to get 2 unshared Nobel Prizes. Nuclear Test Ban Treaty. He was agitating for that for many years, and because you don't have strontium in your bones, you can probably thank him. But he was in his upper 80s then. He had a strange, and I don't remember exactly what his theory of quasicrystals, something called twinning. And he was hyping vitamin C then. You're supposed to take big chunks of, like some hippie. But everyone was just in awe of the man. There he is, Linus Pauling.
The story is that he said about Schechtman, he said there are no quasi-crystals, only quasi-scientists.
Who knows how if he lived to regret those remarks. In 1983, the President of the United States said that he wanted to make nuclear weapons not just obsolete, I think the word he used was impotent, something like that. And that's a good goal. And he wanted to enlist physicists or scientists and engineers in general in that cause, and he was persuaded, I think partly by Edward Teller, that such a thing could be done by putting big, heavy satellites in orbit, X-ray lasers that would shoot down upcoming missiles from the Soviet Union or any other adversary, even in the boost phase, which is very hard. So you've got like 7 seconds to decide whether these are enemy missiles. They threw a lot of money at this topic, and the APS, which had fought in the 1960s over whether to have sessions at their meetings about the Vietnam War and doing research for Vietnam for war-related projects. This was a big issue in the 1980s for the APS and scientists whether to do research. But one thing the APS did right away was responsibly to form up a committee of experts to study the issue, the efficacy of shooting down missiles with lasers. And the results of that debuted at a APS meeting in April 1987. One time that I really screwed up in the timing of things, the session was in the evening, and our press conference was the next morning, and we put out an embargo. An embargo is a troublesome but kind of necessary formality. You tell reporters, I'm about to tell you something really interesting, but you can't write about it until Thursday at noon, to give all the reporters who want to investigate that subject time to get ready. At the last minute, just at the time of the meeting, the evening session, the day before the press conference, the guy from the New York Times called and said, look, your embargo doesn't mean anything to me. The session's going to take place right now. That's the news event. And he was right. So I had to go back and call all these other news organizations and tell them, go ahead with the story if you want to do it tonight, for the next morning's newspaper. So I had screwed up, and I had to make the best of it. Richard Zaire, a chemical physicist, a prominent scientist at Stanford University, compared the SDI machinery to scaling up a Buick. He said, tire technology is really mature. We know how tires work. Let's just scale it up by a factor of 1,000. Windshield, just make a windshield 1,000 times bigger. The engine block, all right, that's going to be trouble, but we know how to make engine blocks. Let's just scale up by a factor of 1,000, and then put it all up in outer space. What's the problem? Well, we know it's not going to work. So some of these New York, so there's the headline the next day. I think in the finest tradition of the APS and physics research, weighing in. So any one of you, if you're on the right committee or make the right discovery, you can have an impact on society. Here on the front page of the New York Times, missile defense itself, it might even be some money for that right now, but the so-called Star Wars version, the space-based version of missiles defense ended pretty much after that. And I think that the crucial factor was the APS study. And as I said, for months, even for years, these are mostly from the pages of Physics Today and Science Magazine. The argument went back and forth. A few prominent scientists said, the efficacy is there, we could do it. And they notified some congressmen that the APS report was filled with errors. The APS responded with a huge subsidiary report that undercut the naysayers. It went back and forth, but finally settled down. Another really, really fun subject, cold fusion. Room temperature fusion. You bring two nuclei together at room temperature. How does it happen? The answer is it doesn't. And this is a tale of two scientific meetings. These two guys here, Stanley Pons and Martin Fleischmann, in the spring of that year, 1989, reported at an American Chemical Society meeting in February that they had pretty solid evidence for room temperature fusion. They had some equivalent of a Faraday's cell, and it's like Humphrey Davy all over. Instead of 1800, now it's 1989, and there's, I forget whether the heavy water, the deuterium, was in the electrolyte or if it was in the electrodes. But they got neutrons coming out, they got gamma rays coming out, they got more energy out than they got in. If it sounds like perpetual motion, it was.
But it is still going on. I mean,
there is research still around the world, and for the 2 months leading up to the APS meeting, I had a phone up to my ear just about all the time. It was fatiguing, but really, really fun. And you're right. The reports continue to this day, and about once a year I'll get a report from not just some schmo, but some senior journalists.
They're big labs.
What's happening in cold fusion?
Labs that were set up with Saudi money in southern France.
Well, I'm only going to talk about So again, in the finest tradition of physics, people at some of the best labs in the world in Europe, MIT, Harvard, Bell Labs, Caltech, dropped what they were doing and went out to see if they could reproduce this. And at this chemistry meeting, by the way, Pons and Fleischmann were met with thunderous applause. And I've heard a report, which I'd like to believe, but I wasn't there, so I don't know, that Harold Firth, an estimable fusion physicist, ran the tokamak at Princeton, was booed at this meeting for seeming to be skeptical about these results. And so the chemical meeting and the APS meeting 2 months later couldn't be different. Well, let me stop. As with the superconductivity, the stakes were enormous. And maybe someday something that one of you does in the lab will catch the ear of Business Week, or here's Newsweek again, weighing in the race for fusion. You see already the scientific debate. One of the neat things about dredging up old news reports is that, look at this. This is 2 months before Tiananmen Square. 100 blossoms were unfolding in China and nipped in the bud 2 months later. But look at this. This is a report of the chemical meeting. Patents sought. At the APS meeting, Mr. Fleischmann and Pons couldn't be there because they were testifying in Congress, and Congress was going to give them tens of millions of dollars. And this was an interesting case. The state of Utah, I should point out that Stanley Pons wasn't just anybody. He was the chairman of the chemistry department at the University of Utah. I think there's somebody from Utah here.
This is before me.
Okay. They couldn't come to the APS meeting because they were just down the road begging for money.
Phil?
Yes, ma'am.
In recent years, the cold fusion community threatened to sue APS because they were putting all the cold fusion sessions on Friday afternoon.
I remember that. Yes.
I didn't hear anything about it at the sorting meeting this year, but I'm going to check out. It's probably in the schedule.
They're
putting it like Monday morning. They don't want to be sued.
Yeah. We would do that. All the detection of God papers would be at the end, but they did have to sprinkle that, maybe even like on a Wednesday. And I was at a meeting once, and a physicist went up to the stack of press releases from one of these cold fusion outfits and threw them in the garbage can. It was something which I wouldn't do. And another reporter said, "Don't do that. You may think this is bullshit, but let's us decide for ourselves, the reporters, and we'll see how scientists react to it." And that's freedom of speech is freedom of speech.
But let's discuss. I mean, since you're representing the reporters love to get a front page article in the New York Times, right?
Yeah, and by the way, you're going to see lots.
Things that they can get.
They can, yeah. I'm going to. I've shown, and I'll show a few more front pages of the New York Times. And why am I glorifying them? Because in my working life, that was the epitome. Nowadays it's getting on YouTube or something like that, but. For the kind of
Malcolm Brown has some responsibility for this too.
Malcolm Brown won a Pulitzer Prize for reporting in Vietnam.
On cold fusion?
Not on cold fusion. So I have some regard for him.
Previous slide.
Well, he's here to report what he saw at the APS meeting.
No, I understand.
Schwinger was on the other side.
I think you're right. There were some. There were a lot of angry physicists at the APS meeting. That's Nate Lewis, a chemical physicist at Caltech. And what he said was, and I have a couple of juicy quotes here. I can accept one miracle, bringing two nuclei really close together at room temperature, and I forget what concatenated things have to happen to get fusion at room temperature. And he said, I can accept one or two miracles, but not three, for heaven's sake. Stephen Koonin was really, really angry. He was a Caltech researcher. He stopped what he was doing. He was later a provost, later BP chief scientist, and later still assistant secretary of energy. A guy from the Deseret News, a Mormon newspaper. We had like 300 journalists, 10 camera crews at this press conference, and this timid person from the Deseret News said, "I'm from Utah, and you're talking about this research going on in Utah. And, do you think that we people from the state of Utah should be embarrassed by all this?" And Koonin said, "Absolutely." He didn't mince words. At another press conference that week, we had Leon Letterman. I forget what the topic was, and he said that these guys, Pons and Fleischmann, should have their scientific epaulets ripped off. Not for making a mistake, but for, and I should have pointed this out earlier, I don't know that they had published, or if they published, they had kept a lot of the experimental, what we would now call methods, obscured, as if they wanted to cover their tracks, and it was just sloppy work. And Koonin and Nate Lewis not only didn't find anything, but they went so far as to explain how Pons and Fleischmann went wrong, and the discussion went so far as to say this was outright fraud, especially on the gamma rays, and there are a lot of ways of screwing up, but they think that there might have been some fraud there in addition. See, some of these newspaper stories, I want to stop because just to the next to the physics, there's a nice little news stories from those years. Cosmic microwave background. It's the biggest thing we can see in the universe, the farthest back in time thing we can see in the universe, and the farthest out in space. Penzias and Wilson using at Bell Labs. Bell Labs was interested in things that would interfere with communications, so they built themselves this big horn, and they saw microwaves coming in from the sky, not from just the Earth environment, and that was, people said, well, that might be the footing of the Big Bang model. It wasn't so great. Now we take it all for granted, but in the 60s it was still provisional. And so the Cosmic Background Explorer was built to measure this all-important background in much greater detail. And the best estimates we had by ground-based telescopes was that, there has to be some structure in this big background, but we don't see it yet. So they would point in that direction, I think they somehow did a differential measurement. They subtracted signals, and then just as important was subtracting out foreground and other background microwave emitters, like the solar system, the galaxy, and then taking into account all the motions of the Earth and the galaxy. And here too, this is a story of two meetings. The microwave, and to this day, I'm not quite sure. The two chief protagonists were George Smoot from LBL and John Mather from NASA Goddard Space Flight Center. And there was some friction, and I'm not sure what it is, about whether to announce the really big results at a physics meeting or an astronomy meeting. And they divvied up the results. I always ran the big physics meeting press conferences, and my friend Steve Marin, he always ran the big press conferences at the astronomical meeting, and he was always teasing me that astronomers get much bigger headlines than the physicists. And I said, "Look, physics is hard. Quantum mechanics. How do you explain that? A planet's a pretty simple thing by comparison." But all right, so we want to know: is there any kind of structure there? Do not look at those desserts on the left. I'll talk about those in a moment. I went to the astronomy meeting, and there, the result that was announced there was the first really best measurement of the temperature of the microwave background. And I don't know if you've ever been, I was at the session, and there was an audible gasp when they laid down, first they put down the red, the expected shape, if the universe was 2.74, and then they you can see the air bars. They're hardly there. And everyone, how many people, show of hands, anybody been to a meeting where somebody said something and there was an audible gasp in the room? David?
Sure.
This IJ, maybe.
What?
This IJ.
No, many things. I mean, I don't know well, you have to define an audible gasp.
Well, something. Wow. Yeah, the gasp would have been when the psi was first seen in the data by the two experiments. All right, so a month later, the other.
The fact is that the remarkable thing about this, not only does it fit a theory,
Yeah.
but it's the most precisely measured black body curve ever seen or measured on Earth.
More than.
I once had a bet with Bob Laughlin, who didn't believe that statement, and it's absolutely true by a factor of something like 1,000. I mean, you can't reproduce this in the lab on Earth. Why not?
You mean a chemical element in the lab can't be?
It's just very difficult to do. I have no idea. I'm not an experimenter. But you can't do it. The universe does it better. It fits fine better than any experiment ever performed.
Yeah.
So the temperature measurement, that's for the sky as a whole. What about here and here and here and here and here and here and here? That would come at the April meeting. And they kept the results very close to the vest. They wouldn't tell me. They wanted me to have a press conference, and I said, sure, anything you say. But they wouldn't, and the day before the press conference and the session were going to be the following morning, and George Smoot comes in with an envelope filled with press releases. And so it's late in the day. But part of an APS press room is schmoozing with reporters, going out to dinner with reporters, and not just to try and get them to write stories the next day, but they're really smart guys, and I like them, and many of them are my good friends to this day. So there's always food out in the APS press room, unlike the astronomy meeting. And we have coffee all day, and the desserts are sitting there. So it's like 5 o'clock in the afternoon, quitting time, and a couple of the desserts were still sitting out there. And the desserts was a creamy, smooth pound cake and a bunched up, messy blueberry muffin. So I said, George, which is it, the pound cake or the blueberry? And he just got this really big grin on his face. He said, read the press release, and we'll talk about it tomorrow. And I went in the next room and I read the press release, and here's the answer. Blueberries. Now, since then, there's been the WMAP detector and Planck, and they've done a much better job. But these variations are 1 part in 100,000, measuring the temperature of the universe across this space. So this was
more like pound cake.
What?
Yeah, it's more like
Sounds more like pound cake.
Pound cake with a little bit of underdone batter.
Can you make a pound cake on Earth that's uniform to 1 part into that?
He's tried, I bet. I'm not the baker in my family. George Smoot, there he is. He must have rehearsed this. Neil Armstrong rehearsed what he was going to say when he stepped on the moon. Well, that's what George practiced saying when asked what it was like when he saw that previous slide. It was like seeing the face of God. So you think that played in the newspapers? You bet it did. A friend of mine was hauled in, and the two of them wrote a book together, George Smoot and my friend, and made buckets of money, which my friend is living off to this day. Once again, the cover of the New York Times, and this time it's the #1 story. And why not? You're talking about the whole universe. Look at this story here. This governor of Pennsylvania, this is 1992, so the presidential primaries were going on. The governor of Pennsylvania said, basically, this hick governor from Arkansas, you mean he's going to be the nominee? He can't beat George Bush, the sitting president. Newsday didn't just have it on their front page, it was the front page. Look at that, the whole page. This doesn't happen very often, folks. I wish it did.
This wasn't hype except for that sentence.
The biggest story there is. Stoplight. This is the one that wasn't a press conference. 2 Harvard groups were competing. Lena Howe had slowed light down to, I remember the cover of Nature. It said, light at walking speed. She'd slowed light down. And she was about to publish a new paper in Nature. And this competing group, Ron Walsworth and Misha Lukin, were working in a different lab, just down the hall. And they were going to publish in our journal, Phys Rev Letters. And the way Nature works, by the way, I think it's published, the public publishing date is the Thursday. And reporters get wind of the top stories a whole week before, with an embargo lasting until, I think it's Wednesday at 2 in the afternoon. After that, you can write about the next day's Nature. But they are really, really tight in keeping, if you write anything, if you break that embargo, they'll take you off their list and they'll never speak to you again. If a scientist breaks the embargo and talks about his or her stuff, they would consider, I knew at least one scientist who had his paper canceled because he was too free. Well, I think he then published in our journal, Phys Rev Letters. So, screw you, Nature. So in this case, I knew that the papers were going to be out within like 2 days, and Phys Rev Letter paper would be out a couple of days ahead. Oh, by the way, here's how it works. A light wave comes in to this material. I forget what the material is made out of. And it looks like as if the atoms are polarized somehow. And then some probe laser beam, the interaction of the laser probe beam with the incoming light signal slows down the light, and the information is vested. The energy and the information isn't absorbed; it's vested in the orientation of these atoms. And you turn off the probe beam, and the stuff's no light coming or going. It's in there. Then you turn the probe light back on, and the process undoes itself, and out the other side comes the information. Anyway, so we've got these two papers, and so I had my blurb ready, and I decided to do something I didn't very often do, and that is give one of my friends an exclusive. I shouldn't admit that out loud. Parents are supposed to be nice to all their children equally, right? And mostly I would give information out about upcoming interesting stories. But this time, I'd been talking to my friend at the New York Times the day before. So I was in a mood to give him a Christmas present. So I told him and not everybody else. I had my newsletter ready to announce it there, like late in the day, but Jim Glantz had gotten this big head start, so he had his story all ready. And it made the front page of the Times. Down there. See, by now we're well into the 90s, and the New York Times has color. Any interesting story there? No. Getting tenure at Harvard. Misha Lukin once told me, partly in jest, but I hope partly in earnest, that this story got him tenure at Harvard. I had to explain myself to some of these journalists the next day. Why didn't you let me know? I said, I forgot what kind of... no, I didn't lie. I never lied, but I made up something. Okay, I'm going to have to go pretty fast now. Neutrino oscillation. The current Nobel Prize laureate, at least one of the two, Arthur McDonald, announced his results at one of our press conferences. The issue then, dating all the way back to the 60s, there was the theory of how many neutrinos should arrive from the sun. I think that was John Bacall. And an experiment was built to detect those very neutrinos, and there was a big shortfall. Only about half of the neutrinos that they expected to come arrived, and you instantly think, well, all right, either the theory's wrong or the experiment's wrong, and it turned out to be neither of those things, because and they quickly surmised, and it became the standard thinking that neutrinos oscillated. A neutrino isn't all by itself; it's really a cat and a dog and a canary, and they oscillate between each other. The three generations of leptons, and then on the way from the sun to the Earth, many electron neutrinos turn into muon neutrinos, and if your detector on the ground isn't designed to detect those, you're not going to find them. This is Sudbury in Ontario. And they did detect all three types of neutrinos, explained the shortfall, end of solar neutrino problem. Could the New York Times bother to come down to this meeting? No, they said, oh, we wrote about it last year, and they've always been that way, that it's news if they say it's news. And you can try and talk them into reporting it, but if they don't want to, they don't. Quark gluon plasma. When you smash nuclei together, gold nuclei at the RIC accelerator at Brookhaven and now at LHC in Geneva, you can obliterate you could think of hadrons as being little bags filled with quarks. A pion is 2 quarks and a baryon is 3 quarks, and they're held together by gluons, and the godfather of chromodynamics is here in the front row. And the goal was to, if you try and separate 2 quarks, you try and saw a gluon in half. It's like trying to saw a bar magnet in half. At either end, 2 new quarks pop into existence, and the hadrons are always color neutral. They're not charged. They don't have net color charge. And my mind is so thick, it took me years to understand why the folks at Brookhaven would announce all these great results. You slam these 2 gold nuclei together, and you get thousands of particles coming out. And there are ways of detecting what, I think, in a manner of speaking, it's the largest man-made, human-made temperature, 6 trillion degrees equivalent, at the heart of one of these nucleus-nucleus collisions. And, somewhere in this gush, I like to think, is a lead ion, so that you're turning gold into lead. Inverse alchemy, which would be sweet, wouldn't it? And they always held back. They announced at this press conference in 2006 that the stuff wasn't a gas as they expected, but a liquid. But they still slightly held back from calling it a plasma. And I guess I figured it out, that what they mean is they really need to determine for themselves that it truly is that the liquid they have does not have any hadrons in it, colorless, chargeless particles, but of truly. And David, I need your help here. Can they say to this day that this is a plasma?
They're just being honest, and that obviously is the problem with the press.
No, I knew they weren't trying to hide anything, but
No, it's just that the conclusion of whether you have one, melted protons, which would be the best way to say it. Protons have been melted.
I know they wouldn't say it that way, but
Of course, the public doesn't exactly know what a proton is. So you have to say atoms melted or something.
atoms, nuclei, protons.
Whatever, but so this kind of experiment, which involves hundreds of collaborators and takes years to come to a tentative conclusion that you've melted protons, And then you've gotten something which is even more exciting because its properties were not, at the temperature, moderate temperatures they achieved, were not predicted. And actually is now ongoing study. It's fascinating. So there are two separate things, and they're not, and there's no, burning signal. It's not like a particle. So particle
Like the
physicists
Higgs.
do very well when
Yeah.
they have a particle.
Yeah.
One thing, a bump, everybody can. Kobe, so all these things, superconductivity, that's easy. That's one phenomenon here. No conductivity and what the temperature is. Some things that are more complex, in a sense, is the responsibility of the people like you, or to put it, to convince the physicist at Rick that, you want to summarize this in one sentence that's a little simplistic, and they don't tend to do it because their audience typically are other scientists. They want to convince them that, well, they've actually gotten deconfined quarks, they've melted them. The evidence isn't overwhelming, but it's very complex. So that's why it's always, particle physicists always a big deal about discovering particles, as opposed to really
Extensive properties.
understanding things like, the discovery of quarks is a good example.
I'm showing this slide here, but to my discomfort, I realize that the movie I would normally click on here is on my computer, which isn't working, and not on Greg's computer. So all I can say is that afterwards, if you want to see it, if I can get my computer working, I can click on that. But this is maybe the most famous photograph of a bunch of physicists ever taken. And the American chemist Irving Langmuir made a 2.5-minute movie of that, home movie. And a lady who wrote a biography of Max Born discovered this movie and showed it at a press conference. So all I can say is I'll show you afterwards, but I can't.
It's on the APS.
What?
You can get it on the APS website.
Okay, yeah. Oh, yeah, yeah. And where did I find it right now? Just going, to YouTube and doing, clicking on Solvay. But it's Dirac comes to life. This is the famous meeting where Bohr and Einstein had their terrific knockdown over the efficacy of quantum mechanics, and you see Einstein and Bohr coming out very straight-faced. It was not a happy meeting, but an important meeting. And then all these other, Wolfgang Pauli, Paul Ehrenfest, kind of larking around, smiling. 2 years later, he put a bullet in his head. It's a remarkable 2.5-minute movie, but I will have to show it later. So that is the end of my talk.
So if someone has a question about a press release they want to write, they need advice.
Or just the wording of a document. I helped one of our Joint Quantum Institute scientists, Nature magazine, liked their paper, but said, can't you write it more in the form of a story? Which I found to be a refreshing thing to ask. So the scientist came to me and said, can we reword this to let the story unfold?
Well, I mean, one of the challenges is that there's a loss in press. I mean, all of us now, there's, Glanz, as we know, is now not doing science writing.
You're a chief in Baghdad for a couple of years.
That's right, and good example of somebody lost to us in terms of ability to report. And he was great. I knew him well at the time, and he would find stories. And those people are extremely rare because now they're all being fed the press releases that we write, which aren't anything like what they would write.
And the newspapers largely just don't bother. There is still a lot of science news out there, but it's on these websites, which, to be fair to them, get maybe more hits than the New York Times ever had readers.
So which websites are you referring to?
What?
Are you referring to the blogs or what?
Well, like New Scientist has a website. Physics Today gets something like 1 million hits a month. That's far more than readers they get, and there are a lot of consolidators. Yeah, some of them not so good, but it's still out there. And specialized. I would write stuff for Joint Quantum Institute and quantum computing websites. There's a whole bunch of them out there. They lap it up. Niche markets. That's the world we live in.
What advice do you have for us? I mean, we're scientists, we speak Latin, but we do want our things to have an impact. And
Short of getting somebody to help you to explain, I would say one is don't tamp down your enthusiasm. If you find yourself talking to a reporter, or especially somebody from or if any of you want to try your hand at writing, the campus newspaper or even your local physics or math department website would be glad to have a couple of paragraphs, readable paragraphs that a visitor or maybe even a donor coming to KITP website, if you had a description of some of the topics at these programs, you could hire yourself UC Santa Cruz. But if any of you want to go even farther than that and want to leave physics and become a writer, UC Santa Cruz has a program. Mostly visiting PhDs will come, not visiting, you sort of give up. I gave up research and I became a writer. Now the way you do that is to go to Santa Cruz for a year and a half and you write and they hook you up with a news publication, and at the end of a year and a half they give you a master's degree, and if you want to, you're now a writer. But writing for a campus newspaper, writing for a physics department website, don't hide your. All right, I guess I have to call on my wife.
Get a non-physicist to read it, says the non-physicist in the room.
To make them excited, and the other phrase I would use, if you can somehow package what you want to say in the form of a reportable result. What David was touching on just now is what I myself fell victim to that. I could not get my mind around what a quark gluon plasma was. Even now, I probably, and he gave a good explanation of why that is. Demonstrating a plasma is hard.
But
that's why
it's not a quark gluon plasma. They just changed the name. They call it something interacting plasma, but it's not what was expected.
But by reportable result.
But the thing that could have gotten a big splash, that was a major achievement, was that they were getting deconfined quark.
Mm-hmm.
They were melting. That in and of itself was. But they were trying to understand something quite complicated, fascinating, interesting, but too technical to explain. But melting atoms is something.
But you really express the dilemma that you get some result that is exciting, and you're telling us that we should really express our excitement to the reporter. How the devil can the reporter tell whether it's
cold fusion,
whether it's David Gross or Lars or the cold fusion? Exactly.
If he's a good reporter, he'll find a second source as well. Most.
But you give us a whole bunch of examples where they didn't.
But I think actually.
But how do we deal with the situation? Look, I've got a whole bunch of good ideas right now. most of them
reportable result with a capital R.
Yeah.
Something actually down. There's something found.
It's much harder for theorists, Jim,
as you know. As I know, yes.
So I mean, they have as big a distrust of theory as everyone else. Period, right? I mean, none of these examples.
He went to theory press conference, yeah.
None of these examples are theoretical. Although I think in the case of ITC, the theoretical excitement fuel is higher. But all those are expensive. So you're talking, by the way, this is the Institute for Theoretical.
I know.
So that's even harder to sell.
Selling theory, in my 5 years at Joint Quantum Institute, I think 2/3 of what I was writing about was theory. So I did it, but it's a hard sell. I mean, they've got no shortage of experimental results there too, but they just sort of fell to me to write up about periphery. I'm going to say more about this in my next talk, maybe a month from now.
All right, well, let's thank Bill. He's here for 2 months. You want to see the movie?